Welcome back, Wisdomers. In our last session, we explored the visual nature of slope. Today, we transition to mathematical precision, and we break down the formal concepts and equations that define it. Understanding why slope is constant isn't just a lesson in algebra. It is the fundamental building block for our entire journey into machine learning. Stay tuned till the end. Let's look at the math. Slope represents the rate of change, specifically, the change in y over the change in x. For a linear equation, this rate is a constant value. Using the example y equals 0.5x plus 1, we can identify the slope as 0.5. It stays the same at every single point on the line. But why? Let's explore the mathematical proof behind this constant behavior. To demonstrate this mathematically, let's analyze the equation y equals 0.5x plus 1. We'll begin at a starting point where x1 equals 2. By substituting this into our equation, we find that y1 equals 2. Now let's observe the change as x increases from 2 to 4. At this new point, x2 equals 4, our y2 value calculates to 3. By applying the slope formula, the change in y divided by the change in x, we calculate 3 minus 2 over 4 minus 2. This results in a ratio of 1 over 2, or exactly 0.5. Stay focused. We are moving toward the formal mathematical proof shortly. To verify the consistency of our line, let's evaluate the slope from a different position. This time, let's set our starting point at x1 equals 3 and observe the change as we move to x2 equals 7. I encourage you to pause the video here and perform the calculation yourself to see if the ratio holds. We are now ready to formalize the mathematical proof that the slope of a line remains constant at every point. By revisiting the two examples we just solved, we can observe a clear geometric pattern. Examine the triangles formed along the line. The vertical segments represent the change in y, while the horizontal segments represent the corresponding change in x. This brings us to the core geometric proof. In mathematics, these are known as similar triangles. Because they share the same angles, the ratio of their corresponding sides is strictly constant. Even though one triangle is larger than the other, the ratio of the vertical change to the horizontal change remains identical. This is why in a linear equation the slope never varies. It is a fundamental property of the line's geometry. Thank you for investing your time in learning with us today. If these insights helped you see data in a new light, please support our mission by sharing and subscribing. Every interaction helps us create deeper and more detailed content for you. Let's continue to build this community of learners together. Stay focused, stay curious, and as always, stay tuned.